Hello everyone.
Recording in progress.
Can you hear me? Hello.
Yes.
Okay. So I share my screen. Can you see my screen?
Yes.
So that is my slide. Okay. So hi and welcome to the third day's training session on Google Earth Engine for beginners. So I am course coordinator and today our third day, and today we will complete these things. So first of all I will try to discuss about that computation using satellite images. So mainly in this part I will try to discuss how you can easily calculate the different types of band, actually different types of indices or different types of raster calculation you can using this. Okay, and then I did introduction to move to the introduction to land cover classification. So mainly in this time here I focus on the fundamental concept of how you can easily make the land cover classification map using the Google Earth Engine platform, and then make the LULC map in Google Earth Engine platform, and then how to export this map as a TIFF format. Then I move to the air quality monitoring. So mainly in this time here I show you that the randomly two data set, nitrogen dioxide or sulfur dioxide, how you can easily import, filter and reduce this Sentinel-5 satellite images for air quality monitoring. Then I also try to show you that the another things for the Sentinel-2 imagery, how you can easily filter this Sentinel-2 imagery and calculate it to the NDWI from these satellite images. Okay, so basically this is our course content, and first of all I will try to discuss about the land cover classification map. So mainly land cover classification is defined by the observed biophysical cover of the Earth's surface, and we can use the land cover classification and land use trend. We can document land use trends and change. We can easily understand by comparing the land cover data result. Okay, and now I will try to discuss about the what's the process to make the land cover classification map in Google Earth Engine platform. So basically this process is the same for all of the satellite images such as Landsat, Sentinel or other satellite images. It will be same, and you can follow this all of the things one by one. So first of all you have to need to selecting your region of interest. Suppose you want to make a land cover classification map for any region, suppose Dhaka city or Bangladesh or other specific region what you need. Okay, so first of all you selecting your region of interest. Okay, you can select the region of interest many way. You can simply upload it on your shape file, and we already discussed about that how you can easily import, upload your shape file. Okay, in Google Earth Engine platform. Okay, so first of all you need to selecting your ROI, then you need to choosing and filtering your image collection. If you want you can use the Landsat or Sentinel, what image you need you can just choose this image and then filter this image. And previous classes I also completed that the part for the filtering the Landsat imagery. Okay, and today I also try to show you that how you can easily filter the Sentinel imagery. Okay, and this is our part. So when you make the land cover classification map you need to choosing and filtering your image collection. Okay, then you need to collecting the training point. So you want to collect the same training point for the specific feature for this is the urban or this is the vegetation or water body. Okay, you can just collecting the some training point. Okay, for a specific feature. So this is the another part for here, and then you need to merge all of this training point. You need to merging all of this training point together. Okay, you need to merge all of the training point. Then you need to make a training data set. Okay, so mainly in this time you can get the training data set by using the image pixel value. Okay, and I also discuss when I want to show you the practically and write this code so that you can easily understand. And then create the classifier. So then you need to create the classifier, and Google Earth Engine has a different type of classifier will be available here, and but in this time this is the introductory course, so that's why I will not go in the depth of the classifier. And I also try to use a normal classifier and classify my image, okay, and then create the classified image, okay, then display the result. So mainly this is the process when you work with make any land cover classification map in Google Earth Engine platform, okay. So now I will try to show you that all of the part one by one, so in practically, so that you can easily understand, okay. So I simply open my code editor, and first of all we need to select our region of interest, okay. Suppose in this time I want to make a land cover classification map for Dhaka district, okay. So first of all you need to just import your Dhaka city shapefile. Suppose I want to make the land cover classification for this region, okay, for Dhaka city. So first of all you need to just import this shapefile in here. You can see it will be imported, and I can simply rename this. Suppose in this time I can give this name is RY, okay, region of interest, okay. Then our second procedure is that you can simply choosing and filtering your satellite image collection. So in this time I want to work with Landsat imagery, okay. You can simply search here this dataset Landsat, okay. Okay, so in this time it is not available here, so I simply go to this browse data catalog and simply search at the Landsat. So I simply click to here Landsat dataset. Okay, so in this time I have used this top of atmospheric Landsat top of atmospheric this dataset top of atmosphere. So I simply click to this dataset, and we already know that about the process for import the dataset and filter the satellite images, okay. We already cover all of this part, so in this time I will go in depth and explanation. So that's why I simply write this code. I hope you understand this. So I simply copy this collection snippet and paste here. After this I give a variable name. Suppose this variable name is L8, okay, and then assign this dataset here. I convert it as the import, I convert it, simply click to here. You can see it will be imported. So now I want to filter my image collection, and we already know that how you can easily filter this image collection, okay. So previous classes I also try to discuss all of the things details, but in this time I just write this code. So I hope you understand this part for image filtering, okay. I take a variable, suppose image, and then I simply call the L8. Then I simply use here the filter bounds function, because I want to this whole collection with intersecting my region of interest ROI, okay. Then suppose I want to make a land cover classification map for year of 2020. So then I simply use here the filter date function, and I simply select here my specific date, year of 2020, 1st January, okay, and I simply put here the in date, year of 2021, 1st January, okay. So I can get here the year of 2020, and I also want to make the land cover classification map only for those images which image will not be more than 1% cloud cover. So I simply use here the filter metadata function, filter metadata, okay, and then I simply use here the cloud cover, and we already discussed about the all of these things, so filtering. So I hope in this time you can easily understand, okay. I want to get here the one, and then I simply want to get from here the mean pixel value, all of those images, which image will be available here, and then I simply use here the clip function for clipping with my region of interest. Okay, so now I want to show this result. So for this, simply use here the map dot add layer function, and after this I simply copy this object and paste here and paste here. After this I simply use here the map dot center object for focusing my shapefile. My shapefile variable name is ry, just put here, and zoom level 10, I put here the zoom level 10, and click to the run. So now I can get the images for the Dhaka city. You can see it will be everywhere, right? But we can get here the totally black and white image. I simply add here the visualization parameter. Okay, I simply click to here, and from here I can use the different types of band combination. Suppose in this time I want to use here the true color, simply put here the B4, then I simply put here the B3, and simply put here the B2, and I also increase the stress 98%. Okay, okay, can you hear me? So can you hear me? Now can you hear me?
Yes, we can.
Okay. Okay. I changed this connection. So I simply share my screen. Okay, I think now it will solve. So can you hear me now? Yeah, can you hear me?
Yes, now your voice is seen.
Okay.
Yes.
Okay.
Okay, so now you can see I simply add here the different type of band combination from here. So I simply use here the B4, then B3 and B2 true color composite. Also increase the stress 98%, and simply click to the apply. So now I can get the true color composite. Yeah, so you can see, and I also import this visualization parameter here. Simply click to here, a new line of code will be added here. I simply copy this and paste here, and gap this the layer name is the true color composite. The true color. Okay, so now you can see our second step is done. So here I can, first of all, I take my region of interest, selecting my RY. My second process is choosing my filter, choosing and filtering my image collection, and display this image collection result. You can see. Okay, so this is my image, and now I want to use this image for making the land cover classification map. And then you can already show that our third process is that we need to collect some training point for every specific feature which I want to classify it. Suppose in this time I want to classify it here from the built up area. I want to classify it here for the water body. I want to classify here the vegetation. I want to classify it here for the bare land. Okay, so I want to classify it here. There are the total 4 classes. So in this time I want to collect here from their 4 different feature for the collecting some training point. Okay, so I can get the training point in the different way. Suppose in this time I simply use here this marker for taking this training point. Okay, or if you have any ground truth data, suppose if you want to take the some training point from ground truth, so you can just make this shape file. Okay, and you can get the some specific latitude or longitude from your ground truth data. You can just make this shape file and import the shapefile and use it as a training point. Okay, so in this time I want to collect the training point from these satellite images. Okay, so that's why I want to take some training point from here. Okay, so in this time I just simply add here the marker, and after this, suppose first of all I want to take the some training point for water body. Okay, so you can see you can simply click to here, edit properties, simply click to here. Suppose in this time I want to take some training point for water body. I simply put this name as a variable. You can use any variable name. I simply use here the T water. Okay, for training data for water, and import as feature collection. Okay, and property, I simply use here this property is the land cover. Okay, you can use any name as a variable, but property name is always same. When you take the urban, this property will be same. When you take the training feature for the vegetation, this property will be same, but value will be changed. Suppose I want to start this value 0, so 0 indicating the feature of water training point. Okay, so I simply set the 0, then I simply click to OK. Okay, so now you can see it will be changed and water, and when it will be black color, you can see now it is the black color, bold black color, and you can simply click on the water body. You can see this is the water body. I simply click to here for getting this training point for water body. Okay, okay, I get the some here the 27 or 30 training point for. Okay, I can take here 34, and then I also want to need for connecting for the some training data for the urban. Okay, I simply click to the new layer, then simply click to here the edit properties layer, then I simply use here the T urban. You can use any name. I simply use here the T urban and import as feature collection. Property name will be same, land cover, and in this time value will be start from the 0, then it will be 1. Okay, so I simply click to the OK, and then I simply take here the some urban from here. Okay, okay, I can take here the some urban, and then I also add here the some vegetation. Okay, I simply click to here, then I simply put here the T vegetation. Okay, and then feature collection, it will be property, it will be just I can simply the same name property. This is the land cover, and in this time value is the 0, 1, and this is the 2. Okay, I simply put here the 2 and place to OK. Okay, and then I simply take the vegetation. Suppose I can simply access the vegetation from here. You can see some green pixel, and this is the another way. Suppose you want to work with a unknown place, which you want to know what's the vegetation, what's the urban, then you need to use here the different type of band combination. Okay, so you can simply I can simply try to see this link. So simply this link here, you can get all of the band combination, and this band combination which a specific feature defined. You can see here, suppose this is the 432, this combination called the natural color, and natural color composite use the band combination of the red 4, 3 and 2, and it replicates the close to what our human eyes can see. Okay, so healthy vegetation is green. So in this time you can see here I use here this band combination. You can see from here I simply use here the B4, B3 and B2. So in this time, this healthy vegetation, it can see the green. Okay, you can see healthy vegetation is green, unhealthy flora is brown, urban feature appear white. So in this time you can see this is the urban feature and it can show the white color or white pixel value color. It will be showing here. You can also see the gray and water is dark and blue or black. Okay, you can see this is the another band combination for 543. Okay, when you use this band combination, it's called the false color composite. Okay, so it's called the false color composite, and it indicated the sum. You can see this useful the analyzing the vegetation in particular areas in red, better vegetation healthy. Okay, so when you use this band combination, when you can see the red color, it indicating the better vegetation. Okay, and dark areas are water. When you find any dark areas, so it identify the water, and urban areas are white. So mainly you can see when I use this band combination, then we can get the another images. Then you can just follow this description and you can collect your training data or training point. You can collect from here. So this is the another part. So this is the another band combination. So it will be indicating the another feature. Okay, when you use this combination, then you can easily identify here the dark shades of green indicate the denser vegetation. Okay, you can see this is the agriculture indices when you use the 652. Okay, so then you can get from here this the easily identify the agriculture area. Okay, this is the geology. Okay, so there is this is the bathymetric. You can see when you use this band combination. Okay, so here we can use the different types of band combination for get the different types of feature. So in this time here I use the true color composite, and true color composite you can see healthy vegetation green, this color will be green. So I simply take here the some vegetation green part. So this is the green. So I simply take the green. Okay, okay, green part, green pixel. Here some green. Okay, green part. Okay, suppose then also some green here. Okay, I take some of the green here. Okay, so I take the sum for the vegetation, and then bare land. So I simply take the another new layer and then simply use here the T bare land. Okay, bare land. Okay, then simply use here the geometry as a feature collection, and property I simply give this property is the land cover, and value in this time it will be 3. Okay, I simply put here. So here you can see I will put the bare land, and I simply take the bare land from here. So this is the bare land. So it has a problem when you work with this. You can see some bare land will be mixing, some bare land pixel value will be mixing with your urban or built up area. Okay, so this is the another difficulties when you work with this, but this is the introductory part. So in this time I will know go in the depth for how you can easily remove it. Okay, so, but it will be possible for differentiate between the bare land as well as also differentiate the built up area. Okay, so in this time here you can see when I run this get this LULC map, you can see some bare land will be changed into the urban. Okay, so you can see this problem because it will be almost same this pixel value, so that's why it will be created this problem. Okay, so I take the some bare land from here. Okay, so now you can see I can get here the some specific training feature for a specific all of this classification. Okay, so now I want to merge all of this training point together. Okay, so then I simply take a variable you can use any variable name. Suppose in this time I simply use the variable name is var. I can simply use here the class names. Okay, you can use any variable name. Then I need to merge all of this training point. So here I use the, you can see t water. I simply use here the t water, then simply use here the merge function. So after less than 1 minute I will send you the Zoom link again. So please join again. Okay, it will be merged with the tr1.